Hello, good evening. Can you hear me?
Yes, sir. Good evening, sir.
Okay, good. Okay, so basically in this time you send me your one problem. So that's why basically it's a data extraction. So for a specific boundary. So just I will show you that process and also send you the code. Then I can easily get all of data. Okay. So
Yes,
let me
sir.
share my screen.
Okay.
Can you see my screen? Is it visible?
Yes, sir. It
Okay.
is visible.
Okay. So in this time you want to suppose precipitation, wind, humidity, elevation. Suppose this type of data, how we can easily get for a specific boundary. In this time I talk about that. And then we just try to show the result for this study area. You already sent me the shape file. So first of all,
Yeah.
suppose elevation. Elevation I do use here, suppose SRTM, NASA SRTM dataset. NASA SRTM. I simply search on the Google or search on the search bar. Simply search. No issue.
Excuse me, sir.
Yeah, please.
Yeah. Before we start to the specific point, can you access my companion mode i- in Google Meet?
Okay, so can I? You can also share the screen. Then I also check it. No.
I mean, in the Google Meet, can you accept my additional companion mode? I need to use two screen, double screen. So if you can accept in the Google Meet, I I go for the companion mode.
This
Okay, no
one.
problem. I asked for wait, okay. Let me try it again.
Okay, okay. So you can see NASA SRTM, the
Oh,
elevation.
yes.
Okay. Just I simply copy this ID to this data set. So it's a provide our elevation data and it show the result for is the meter 30 meter pixel. Pixel size is 30 meter. So just I simply copy and paste here. And I take a variable name. You can put it in as a variable. I put the name suppose M. And further I just put here the select function and I select here specific one band which is elevation. I copy and then paste here. And further I want to show this layer. So map dot add layer and put here the dim. So click run. So now our dim or elevation data is okay. We can get it for our study area because we can get this type of map. But we have to also use a function clip function for our study area. So just use here the clip with our boundary. This is ROI. Just click the run. So now it just clip with our shape file and we can get the result for our only for our boundary. It look like that. You can see the result. So now I want to add the visualization. So I want to add the visualization from here. So just click on the setting properties and I simply set here that stressing 98%. And I want to set the color. Suppose I want to set the color for low elevation type of color. Was greater than I want to set this type of green color. Greater than I want to set this type of yellow color. And high elevation I want to set suppose this type of red color. So it's a high elevation about that. So now I simply apply. So now this visualization is set in my code. We can easily get it. You can see this type of visualization. And further, this visualization I have to import in my code editor. Simply copy the visualization parameter and paste after the object name. So just I paste here after the object name. I put here the layer name, suppose elevation. You can put any name as a layer name. I put the elevation. So now we can make the elevation about that. And further, I take the another data set, suppose precipitation data set. I want to check about the precipitation. So making this precipitation, I simply search here another data. It's called the chart satellite imagery. So basically, there's a lot of data set we can easily use. In this time, you can see the charts daily and panted. So both are the same. Daily mainly provide you the daily data set, and panted mainly provide you the data for every 5 days interval. I simply click on the panted 5 days average data we can get from here. And further, you can see about the time period. Okay, suppose which time you want to need, you can also get the precipitation. Simply select the time period. So just I simply
Yeah,
copy that.
sir.
Yeah, please.
Is this the most accurate one? Eh,
Which one?
That rainfall data, that
Yeah.
chart
So
data.
yeah, charts is also okay. No problem. It's also okay. No problem. Okay. Basically, this
Okay.
charts data is also you can see with the station data is the combined with that satellite data also combined with station data. Okay. But it also work well for the big study area because this resolution is not much good. You can see it is the 5566-meter resolution. So let's check. We try to use the data set. I simply copy these things from here, banded, and further I just paste here and then give a name. I put the name suppose rainfall or you can put a name rainfall equal. I just put here that select function. So put here the select and put the our specific band. This is called the precipitation. You can see this is the band name about the precipitation millimeter per pented. So just I paste here and I need the data suppose specific time period. I put the filter date and put this time suppose year of 2020 or 24 suppose 1st January from year of 2024 or any time period. You can still put your time period, your study time period, simply put it. It's 2024. Suppose 0430. I put this and if April. I can see the last time period. What is that? Last is time period the 0426. 0426. Okay. So it is updating. We put here the 0426. 26. Okay. So now I calculate from here that total precipitation. Put here the sum and further click with my study area which is ROI. So now display this result of rainfall map. Map dot add layer and call the rainfall. Okay, then click run. So now it will be added that rainfall map for your study area and which come from the chip satellite imagery. We can get this type of white color, but we can easily set the color combination from here. So just click on here and set the color. So the stress carton is stressing 98% and plate it and then click on here. Then this time for the low precipitation, I want to show this type of suppose this type of color. It show the low precipitation. And then greater than high, I want to show this type of yellow color. Greater than high, I want to show suppose this type of green color. And high precipitation area, I want to show this type of blue color. It's the high precipitation. Then apply. Now we can got this type of map here. You can see. So basically, this type of region is show about the low precipitation area, and this type of region you can see. We find out the high precipitation area. So this is our precipitation or rainfall map we created. Simply click on the import button from the visualization parameter, and then copy the variable name, and paste in here, and further just put here that it's a rainfall. Okay, done. Further, we talk about that wind speed. So basically, you can see about that wind speed. You want wind speed and humidity. So for the wind speed, we can also use the another data set. Suppose I simply search here wind speed. So here you can see about that wind speed global. We have to use this. Let's check it data. It's the ocean. It's the ocean. It's not the. It's the ocean wind speed. You have to check this data. So it's the sea surface. It's the sea surface temperature. It's not. Suppose let me check on the wind speed. Wind speed. Okay, so let me open my previous code for wind speed. Okay, so velocity. This is the formula about that wind speed. Okay, just I simply copy from here the full code for the wind speed. Okay, and further we just try to add the velocity. Oh, simply copy and I just paste here. Okay, so in this time we just calculate the velocity about that, or I put the time period, any time period you can put in here. Suppose here up 2000. You can say check about the data set first. This is the data set we use in here, ECMFMW. So basically this data set provide you that wind speed also. It's the climate reanalysis data. It's globally available for that. From here we can just find out that wind speed. So for that we have just used this data set, and you can see about that time period about this data set is that we can get the time, from 1950 to present time. All of data you can easily access from here for the wind speed about this data. Okay, so for this time, in this time we are just use here this wind speed data, and we just put here the filter bounds mean and clip with our ROI. Okay, so clip with our ROI need, and terminal velocity we calculate this type of velocity, and further we just click the run. In this time it also added another layer which calculated the velocity of wind. You can see it also available. So from 1950 to 2024 041. So there's a lot of data we can get from. We find out this type of things. I want to add the velocity visualization. So for that, I simply just stressing 98% for better looking about my map. And further, I want to check about that. You can see 0.19 meter per second. Okay. So for the low velocity, I want to show this type of color. Okay. So for the low velocity, I want to show suppose this type of pink color. Further high, I want to show this type of green color. Greater than high, I want to show this type of yellow color, and very high I want to show this type of yellow color. So now further I want to apply this thing. So now we can get that wind velocity map for our study area. So this is our wind velocity map. We can easily get it from here. You can see it look like that. In this time we find out this type of region. We find out the high velocity of the wind. Okay, you can see it loaded. So just I simply import this wind velocity map in here. Just simply import the visualization. Simply copy and further paste in here. Just paste. And finally, I want to talk about that your humidity. So for the humidity, we can easily calculate that humidity data. Set from here. Humidity, I simply search here. Now I can get all of humidity related data. You can see data set, primary humidity, tropical forest, famine early warning system. We just try to use the data set. Land hourly. So this is another data set. Land reanalysis data set. It also provides you that humidity band also. So here you can see about that. I simply search Control F and find out humidity. So dew point temperature 2 meter above. Temperature of the 2 meter above the surface would be able to cool and it can be related to humidity. Used to combined with the temperature and pressure, it can be used to calculate the relative humidity. So 2 meter dew point temperature is calculated by interpolation between the lowest model with the Earth's surface, taking the account of atmosphere condition. Okay, if you want, you can also use this dew point temperature 2 meter as a relative humidity, but I want to use the more correct data. So check for that. Let me find out. Global land assimilation system. We try to use the dataset also for humidity. Okay, you can see the specific humidity we can get from here. Okay, so specific humidity I have to calculate. So further we have to use this band to get this humidity result. Okay, so let's check. We try to use the data. So first of all, simply copy this data set, land data assimilation system, and then paste here. I put this name of the data. Suppose I put the name. It's a humidity. Well, this. And first of all, simply call this band. When I want to use in here. So my band is that you can see his band name is that uh QIR. This is the band name about that. We copy and then paste here. I simply put the specific time. Suppose I put the time is that filter date and put the time for year of 2020. Suppose 1st January from year of 2020 December 31. Okay, and I have to calculate the mean or average result, and then it click with my study area, which is ROI. So now display the humidity map. So map dot add layer. Call the humidity. Click on. So now let's check result about this humidity. It loaded. Since it loaded this data. Okay, it loaded. Yeah. For humidity, I want to set the color plated also. Then custom stressing at 98%. Right. Okay, so further I want to add the color. So simply click on here. Suppose I want to show here the low humidity, it show as a red color. At the get at then I need to show suppose this type of yellow color. Get at the end to show this type of blue color. Get at the end to show this type of blue color for high humidity value. So now further apply it. So now I can get this type of result. It loaded. And further I also try to import these things in here. Just simply import and copy this visualization parameter and paste after the object name. Just paste after the object name and put here that the humidity. So now it loaded one by one all of data. So this type of blue color identify about the high humidity region and red color identify about that low humidity region. So it loaded. It's a very big data and this pixel size is also big. That's why you can get this type of breed about the humidity, the velocity, rainfall, elevation. Not only for that, lot of data so we can easily access from Google Earth Engine. And further we can easily visualization the map and also export this type of things from here.
Okay, sir. Then I may need all these wind, precipitation, and humidity data in CSV file.
Yeah.
What should I do?
Okay. Okay. So I'll send you this code link. You also try to check it further, all of this result. And you can easily export all of that data. I already discussed a lot of times. So this is the export image, yes, to drive. Okay, just use this code function and which code you which image you want to export. Just simply write this variable name and then you can easily export it. So all of humidity, rainfall, precipitation, or any other imagery which you want to export, you can just use it. Okay,
Okay.
so I will send you this code. You'll also try to do that. I hope you can easily get this solution. No problem. Okay. Okay. Thank you.
Okay.
Thank you. Okay. Bye.
Thank you, sir.